So till now we have been working on Spider. So from this tutorial, let us see a different tool. Okay, so we would like to work on Jupyter Notebook. So let me just launch Jupyter Notebook first Anaconda, and then we can launch Jupyter Notebook. Other way is just launching a command prompt. So you can just run a command prompt like this, and you can run Jupyter Notebooks. So just like in the previous session, we had just ran Python over here itself, right? So instead, you can just type Jupyter Notebooks, Jupyter Notebook. So if you give enter, you will get it. The other way is launching Anaconda, and over here in Anaconda, you will be finding Jupyter Notebook, which will be pre-installed. So it is just a web-based interactive computing in notebook environment. So basically, here what happens is, like as I had discussed in the very first couple of sessions, that Jupyter Notebooks is like I consider it as a combination of an editor as well as an interactive console. Okay, so you can work on Jupyter Lab also, which is an extensible environment. So I'll be working on Jupyter Notebook. So I'll just run from here. It doesn't matter. You can launch it from different ways. So here we have got the Jupyter Notebook. So maybe I just want to create a repository. Okay, so let me just cancel this. Okay, so we'll go to desktop. So that is where we have saved our Python files also, right? Python scripts. So here I'll create a directory known as maybe JP. Okay, Jupyter, maybe JN. Okay, so oh, sorry, it is MK directory. So if you are not understanding, you just go open the file which and all we had created earlier. So that is nothing but the Python scripts. So over here I have created a new folder. Okay, I have created new folder using a command prompt. That's it. So make directory is the one. So let us go in this directory and launch Jupyter Notebooks. Okay, and why exactly am I launching over here? The reason is very simple. Wherever I launch my Jupyter Notebook, over there the environment will be created. Okay, so basically here we'll be working on base environment. So here you can see the notebook list is empty. Else if I launch in a different directory, so this will be my something known as a root directory or the base of the directory. So here we would like to create a lot of notebooks. Okay, so again it is pre-installed with all the site packages. So similarly in the previous session we saw about numeric Python, right, which is installed in Python. So under site package itself. So similarly over here also we will be having Numpy installed. So let us go ahead and create a new file. So here you just can give new file, select new file and Python 3. So it will just open in a new this one. So basically this will be launched in a browser. Okay, so it is a web-based application, and here you have consoles. Okay, so maybe I want to print hello. We'll just go with the tradition hello world. Okay, so to execute this there are a lot of shortcuts. So if I give enter, it is going to next line so that I can type more. Okay, so to execute this command shell at a time, you need to give shift enter. Okay, when you give shift enter, it will execute this line, also displays the output, and it will create new cell. Okay, so basically cell is like, again as I was telling, it is combination of editor and the console. So whenever you are giving shift enter, it is creating it is executing and creating a new cell, whereas if you are just giving enter, it is going to next line. So maybe we can add comments. So let us go ahead and start working on our numpy itself. So import numeric Python, so numpy. So for that we need to use import numpy, and also you can import modules with a different naming as you like, as you prefer. Okay, so maybe for example I don't want to use numpy everywhere. Okay, so for example we were using for like maybe indexes and all, right? So we was giving name. So similarly here also we need to give hierarchical naming with respect to index. So I can import it as np. Okay, so wherever I tell np in my particular this module or sorry, this Python file, over there it will be addressed to numeric Python. Okay, so that's how it works. And here I can tell maybe I can write a message. If I don't get any error, I can tell package successfully imported, something like that. Okay, let me just execute that. So it is telling package is successfully imported. If you just run this statement, so I can just rerun this. So I can just comment this out and rerun. So you can see there is no output printed. So just for getting the output listed, you can do. Okay. So now again with respect to this one, I would like to have a quick comparison with the list. So we'll create a list and then also see how this list can be used as an array, how we can create an array with respect to numeric Python. So let us create a list. So maybe you can't use the keyword list. So I'll just call it as list variable, okay, which holds the list value, and basic numbers. I'll just use whole numbers 1, 2, 3, 4, 5, 6. Maybe you can give as much you want. And now let us check which type it is. So print list var. So that will be nothing but our list itself. It is self-explanatory. And then maybe you can print out the list var itself. Okay, so we'll just print out what exactly it is. So okay, so this is type. Apologies, I just missed out the type. And then we'll be having list variable. So list variable, and maybe we can execute this and see. So there is a syntax error over here. So okay, I have to close double parenthesis. So whenever you get an error, you can rerun this. Okay, you can modify over here the error, and you can just give shift enter again so that you can get it. And also it is telling class lists. Okay, so even class, the lists are actually defined as between a predefined functions of classes. So even our Numpy is actually a class itself. So again, class-based approach, you can understand it better. Now let us create list to an array. Okay, so let us create list to an array. Okay, so I'll name the variable also in the similar manner. So list to an array. So now what I need to do is I need to use Numpy. So instead of calling it as Numpy over here, I'll be calling it as np. So np dot. So if you're wondering what exactly these values are, you will just will go over here and search as numeric Python. So Numpy. Okay. So numeric Python, here you can find many things over here, and also a few introductions and all. So you can go ahead, check. We need I'm interested in Numpy documentations. Maybe you can go with PDF installations, so many things. Okay, so here I wanna go with getting started. Maybe over here you can see it is already installing, which I had discussed in the previous session, and this is how usually we import it and all this stuff. Okay, so I need a user guide. Okay, and in user guide I am particularly interested in with respect to uh, methods which are inbuilt in it. So maybe I'll search as Numpy docs. Okay, it is giving back to the same one. Okay, it is giving with respect to this one. So I am interested in methods. So yeah, maybe you can go and get some kind of docs like this. So here you can see array objects, and in array objects I had mentioned ND arrays, right? So n dimensional arrays. In the previous video we had already seen this. So if you just go over here, you can see they are using something like np.array. Okay, so this is a method which is present under our array. So I had also mentioned many other arrays in the previous session, right? So they were like one is obviously our array, and then we also saw about a few more like reshape, dtype, and then shape, slicing, random, and all I had mentioned in the previous video, right? So those are the things. So first thing is to create an array, we need to use this, and also here you can see lists are passed. So similarly, let us work on it. So now what I can give is maybe the same list. So before that I need to use the method known as array. Okay, and if you need documentation of anything, you can actually check in Jupyter Notebooks itself. So just click, you hold shift and press tab. So here you will get the doc string. Okay, so if you recall when we had created doc string functions, so this is how the doc string is created for that array. So if you just click this plus over here, it will just expand. So here you can see how exactly you need to define, and also with respect to naming I was telling, right? So here d type is none by default. Okay, so that is not added, and also copy is true, and some many other. So we'll discuss more about all these parameters as we get more into the course. So over here I want you to just observe that first we are passing an object. So this object will be nothing but our list. Okay, so if you see here, it is like array like. So any object exposing to the array interface, and whose array methods returning an array. Okay, so basically it will get some kind of object which is like an which can be added to our array interface, and it will be returning the array. Okay, so that is what is returning over here. So npy.array is also a function which will return values. Okay, so the returned value will be in form of an array. So let us see how exactly it will be working. So let me just go ahead and give my list over here. So my list over here again, it's a function. We need to open parenthesis and close parenthesis, then send. Okay, so I'll directly, maybe I can send list var itself. So I can send directly this list itself. Okay, again you can't give 1 comma 2 comma, it will become a tuple, and also it will be wrong because it will be sending multiple arguments than sending what exactly it is. So it should be enclosed by bracket. So maybe we'll see about how exactly we can do in tuple. So here we have created an array. So let us print similarly over here, print the value and also type of it. So let me just copy this same thing over here and just change the variable name, and let us just execute that. So here it is telling numpy n dimensional array, and this is the array. So it is returning something similar to list, but here you don't find any commas. Okay, so that is what is happening over here. So similarly we can do tuples. Okay, so maybe tuples you can use for flower parenthesis. So I'll call it as, okay, tuple var. So I think I just want the remaining same, and I'll just replace. So I'll print the type and also the tuple itself. So let me just go ahead and execute this. So it is telling sorry, it is a tuple. Let me just change the brackets. So that is the main difference between tuple and a list, right? So here you can see it is class tuple and it is re-executed. And notice that every time I'm executing one of the cells, the number over here is incrementing. Similar to a console, but in console it will be like 1, 2, 3, 4. Here I'm re-executing it. So basically previously it was executed. Our the variable name only is pointing towards a tuple now rather than a list at this scenario. So that's why it has been lost over here. But still, like if you want to check any other values, you can definitely check. But here it has been replaced, so that's why I won't be importing. Okay, so here previously I had printed, so here also I can't see. Okay, as we work more, maybe we'll get into that. So now let us use this tuple. So I'll just copy the same thing over here, and maybe I'll call this as tuple to array. Okay, so tuple to array, and I need to pass the tuple var instead of list variable, and let us print the type and this one itself. So here you can see it is again still class of nd array. So it doesn't matter whether you are passing a tuple or a list. Ultimately you will be getting the same kind of output. So basically I mean it is forming an nd array, and the array is represented in this way. So you can see here the array is same as that. So that is how it is working. And also it can be multi-dimensional. It need not be one dimension. So this and all is actually one dimensional array. So let us see about two dimensional array. Okay, so how will we declare two dimensional array? It is very simple, by just separating with brackets. So that's why I was telling you need to have square parenthesis in it. So maybe I will use two dimensions for one. I shall pass list variable, other I can pass tuple. So basically how we can do is I'll just call this and name as array underscore 2d. So 2 dimension. This will be equal to again same np dot array. Okay, so here I need to pass maybe a list of both tuple and this one. So a list of, maybe I will just send the list var first, or maybe this is confusing. Let me just declare it manually. Okay, so let us do that. That would be better. So I'll give 1 comma 2 comma, okay, 1 comma 2 comma 3. Okay, comma another list. Okay, so again this is list of list. Okay, that is how I am passing. So basically internally it is getting separated, right? So that is how it will be converted into 2-dimensional or 3-dimensional array also. Okay, so if you want 3-dimensional, maybe you need to open another parenthesis. So in a minute we'll be seeing that. So here what can I pass? Maybe the remaining numbers 4, 5, 6. Okay, so again let us just print out our 2-dimensional array. So print array maybe I'll send a string also to tell it is array 2-dimensional. Array 2D is equal to, and do remember to give spaces as it is holds a character also. And now I can just pass in array underscore 2D. Okay, so let us just execute this. So we have a type error over here. So basically I'm missing some kind of brackets. Yes, I have to open another brackets over here. So as I was mentioning, like it should be list of lists. Okay, so I'm missing that. So I've added that. Let me just execute that. So here you can see it has been executing. So like here it is, I'm not able to figure out how, whether it is like 2-dimensional is nothing but matrix, right? So I'll give a slash n. So backslash n will create a new line. Okay, so this is kind of escape identifiers. So let us rerun this by shift enter. So here you can see it is like kind of a list of it's an like a matrix. Okay, so here 1 2 3 row 1 4 5 6 in row 2. So it need not to be this one itself. Maybe you can give values like 1.0 1 2.5, and third one you just leave it and we'll just execute and see what happens. So for 0 and all it is not showing. So everything in the list, everything in the array, it is converting into a floating point. Okay, so basically here we are getting floating numbers. So this is how you will be creating an one-dimensional, two-dimensional. Maybe you can create three-dimensional. I'll just copy this. For three-dimensional, you will be having uh, again one more square brackets with respect to another square bracket. So basically, what I'm telling is you will open over here, and maybe this is getting complex. So let me just put it in new lines. Okay, so this is a two-dimensional array, and here comma another two-dimensional array I need to open. Okay, so maybe I will give these values as 2 4, 3 4 something like that, comma enter, again another 4, some 3 values. Okay, so this forms a three-dimensional array. Hope I have done with all. No, I need to close one more bracket. Okay, so you can see here there is green color highlighting. Okay, maybe I'll zoom in a bit. So here you can see if I click over here this common brackets, there is an highlighting. So this is the advantages features which are provided by most of the editors as well as the Jupyter notebook what we are working over here. So this is an three-dimensional array. So I'll just call this as 3D and we'll also print it in this similar way. Okay, so we'll just print it with 3 dimension and see how exactly it is. Again, visualization three-dimensional figure is this is not possible over here. So maybe we'll see that in matplotlib. Okay, let us just execute that. So here you can see it is like 3 dimensions. So this is like the first row, first column, and maybe first axis, and this is the first row, first column, but second axis, something like that. Okay, so 4 dimensions, 5 dimensions, everything is done. So that is about creation of numeric sorry arrays in using Numpy. In the next video we'll be seeing a few more applications, how it can be edited, or with respect to all the methods we'll be seeing examples.